3.7b, I can write and solve systems of equations. So a few class periods ago we solved systems of equations by graphing, where we had to graph two lines and see where they intersect. We're doing the same thing this time, but with story problems. So I wrote down the steps for you. The first step is to define your variables. That means say what x and y represent. For me, it's always easier if I make y the one that's greater. And that just makes it so I don't have to deal with a negative y-intercept, but it will work if you do it the other way. Next, you write two equations. You have to put them in slope-intercept form so we can graph them, and then you graph the two equations and see where they cross. So for the first example, it says Susie has 7 people in her family. There are 3 more boys than girls in her family. How many boys and how many girls are in Susie's family? So I have to first define my variables. Again, I make the y value, or the y variable, represent the one that's greater. So I'm going to make y be the number of boys, and I'm going to make x be the number of girls. And so I'm going to write two equations. So one of the equations is going to come from this sentence. Susie has 7 people in her family. That equation is going to be x plus y equals 7. The problem is this equation is not in slope-intercept form. So I said the number of girls plus the number of boys is 7 people total. I need it to be in slope-intercept form so I can graph it. So I'm going to use what I know about solving equations. X minus x is 0, so I have the y by itself. I'm going to put the negative x first so it looks closer to slope-intercept form. So there's one of my equations. My second equation is going to come from this other sentence where it says there are 3 more boys than girls in her family. That means the boys equals the number of girls plus 3, because there are 3 more boys than girls. So there is my equation for that one. And then I'm going to make my graph. So I already know x measures the number of girls, y measures the number of boys, and I'm going to, if I go by ones, it will work. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I didn't have to change this equation at all because it's already in slope-intercept form. So for this equation, my y-intercept is 3. My slope is 1 because there's an invisible 1 in front of the x. 1 as a fraction is 1 over 1, so I go up 1 to the right one, up 1 to the right one, up 1 to the right one. So then there's one of my lines. My other line, this one up here, I have a y-intercept of 7. My slope is negative 1 because there's an invisible negative 1 in front of the x, and then I go down 1 to the right one, down 1 to the right one. And again, where the two lines cross is my solution. So these two lines cross at 2, 5. So that means I have 2 girls and 5 boys in the family. So I'm going to write that up here because I'm out of space. 2 girls and 5 boys. Now I know you could have solved that one without graphing. And we would normally use a method like graphing when we had much bigger numbers, but because that would make our graphs huge, I've chosen smaller examples. So I know in real life for a problem this small you wouldn't use a graph, but I still need you to show all of the steps, including your equations and the graph, so that I can know you understand this method. So for example 2, the sum of James' age and Sarah's age is 10. Sarah is 2 years younger than James. Find the ages of Sarah and James. So I'm going to define my variables first. I'm going to make the y the one that's greater, so y is going to be James' age because he's older. Again, it won't be wrong if you do it the other way. It'll just have a negative y-intercept, so it won't fit very well on this graph. You could use a different graph though. And I know the sum of their ages is 10. It says the sum of James' age and Sarah's age is 10, so that means if I add their ages, I get 10. That's not in slope-intercept form, so I'll subtract x from each side. So I have y equals negative x plus 10. Now that's in slope-intercept form, so it's easy to graph. Then I'm going to write the other equation saying Sarah is 2 years younger than James. So I would say, if Sarah is 2 years younger than James, I would say James' age minus 2 years younger than James, is Sarah's age. The problem is this is not in slope-intercept form, so I'll add 2 to both sides. So I have y equals x plus 2. That is in slope-intercept form, so I'm ready to graph it. I'm going to write it over here a little bigger so it's easier to see. So I need to label my graph first. The x measures Sarah's age, and the y measures James's age. And then I need to label my axes. Again, ones will work just fine. 1, 2, 3, 4. So I'll graph this one first. The y-intercept is 2. The slope is 1. This other one, the y-intercept is 10, which is actually going to be up here. The slope is -1. Whoops, should be right here. Not over here, that's -1. Oops, I'm getting a little not straight. There, so Sarah is 4 and James is 6. Sarah is 4 years old. James is 6 years old. Again, I know you could have done that using logic, but I want to make sure you understand this method, so I need to see all of this work. So 4 and 6. The next one says, Aaron has 24 people at his party. There are twice as many boys as girls. How many boys and how many girls are at Aaron's party? So I need to find my variables first. There are more boys than girls, so y will be the number of boys. X will be the number of girls. There are 24 people at the party total. So that means boys plus girls equals 24. That's not in slope-intercept form. So I get y equals -x plus 24. That is in slope-intercept form. The other one says there are twice as many boys as girls. So that means the boys equals 2 times the girls. That one is in slope-intercept form, so we're ready to graph. This one has a y-intercept of 24, so I know it won't work if I go by ones on the y-axis. So this is number of girls. This is number of boys. I know I'm going to go by 4s on the y-axis because I have a y-intercept of 24. So 4, 8, 12, 16, 20, 24, 28, 32, 36. And then I'm going to go by, I'm still going to go by ones on my, I don't think I want to go by ones. I'm going to go by 2s on my x-axis. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, my purple equation has a y-intercept of 0. The slope is 2, or 2 over 1. But I need to be careful because of my scale. Going up 4 over 2 is the same as going up 2 over 1. So this one doesn't look like a slope of 2, but it is because my scale is different. I'm still going up 4 over 2 every time. The green one has a y-intercept of 24, has a slope of -1. That does not mean down 1 over 1 in this case, because down one box is going down 4, and then you go to the right 4, so I would go to the right 2 boxes. And then down 4 to the right 4, which is the same thing as -1. So my lines cross at 8:16. This is what I need you to submit when it says to submit the video. Submit 8:16. That means there are 8 girls and 16 boys at Aaron's party.